Hi guys, and now that you know how to work in Radians, it's time that we look at the arc length and the area of a sector in a circle. So Radians was all about arc length really, and arc length is this length here. Arc length is the distance you travel along a circle, and we know that for 1 radian the angle theta here, if that's 1 radian and the radius of the circle is r, then the arc length here is r as well. That's how radians are defined. Yeah? So for 1 radian, theta 1 radian, the arc length is the same as the radius of the circle. Now how did that work all in degrees? If you're in degrees, you know that the circumference of a circle, the full circle, is 2 pi times r. And the area of a full circle is pi times r squared. Now if you have an angle theta and you want to know the arc length here in degrees, then the angle theta needs to be in degrees, of course. And you can work it out like this. You take the angle theta, sorry that's a bit messy, isn't it? And it's in degrees, out of 360 degrees, because that's a full circle. And you multiply that by 2 pi r. So that's the arc length L in degrees. If you wanted to have the area of a sector, so the area of a sector, that would be this area here, the piece of the pie, so to speak. That area in degrees would be theta degrees over 360, because that's the proportion out of 360, multiplied by pi r squared. Now in radians, when you work in radians, things can be simplified. So let's have a look. Because if you look closely, these formulae here, these two, are already put in radians really, because they have a pi in them. They have the pi symbol. That means they have something to do with radians. So working in radians is easier. The arc length, if theta is an angle in radians, it is theta out of full circle, which is 2 pi, multiplied by 2 pi r. And you can see that the 2 pi bit cancels out. So what's left is theta r. So the arc length is the angle multiplied by the radius, if you work in radians, which is far more simpler formula than what we had before. The area of a sector is similar, theta over 2 pi, which is full circle, multiplied by pi r squared. This time the pi cancels out, just a pi. So we have theta r squared over pi. Area of a sector is the angle in radians multiplied by the radius squared over pi. So 2 new formulae to work with.